Good day mga ka-CRT. For this video lecture, I'm going to solve sample problem set number 3 in Physics/Dynamics. So let's begin. Please take note in solving the x and y component of a force, I'll be using the following concept. So there are 4 possible scenarios wherein we have to solve the x and y components of a force. Let's say the force lies in the first quadrant. We need this angle. So if this is force F, x component is equivalent to F, and the trigo function cosine of that theta. While for Fy, this is F sine theta. If the force lies in the second quadrant, we need to get the theta with respect to this x-axis, the negative x-axis. Okay? Then if this is F, so the F component or the x component of F here is negative F cosine theta, and the y component is F sine theta. Okay? Third scenario, if the force lies in the third quadrant, we need to get and locate the theta here. If this is F, so the x component is negative F cosine theta, and the y component is negative F sine theta. Then fourth scenario, if the force lies in the fourth quadrant, we have to get the theta here. And if this is F, the x component is F cosine theta, and the y component is negative F sine of theta. So as you can observe here, we need to establish first the angle theta as shown. So all of the fx will be solved using the cosine function, and all fy will be solved using the sine trigonometric function. So this is our first example. Find the acceleration of the box if the force P equals 1000 Newton and the mass of the box is 100 kilograms. Assume frictionless. So let us draw first the free body diagram using the incline as the x-axis. So this is our x-axis. So let's draw the x-axis here. Okay, and then our y-axis. So the direction of P going in this direction. This is the direction of the P. So the movement of the box is also going in this direction. Therefore, the acceleration is this, going to the right, and in parallel with the incline or the x-axis. While the effect of the weight of the box, it will be here in the third quadrant. So this is the weight of the box, and the given angle alpha is 30 degrees. So this is the angle 30 degrees. Okay? So let me redraw the FBD or the diagram here. So this is force P, and this is the weight of the box. And as explained earlier, the needed angle is the angle here. So if this is 30 degrees, this is just 90 degrees. The whole third quadrant angle, 90 degrees. Therefore, this is 60 degrees. Okay, so let us now solve the acceleration from the formula F net. The net force equals mass times acceleration. The direction of the acceleration is going here. Therefore, all the forces going in the direction of A is positive. For the F net, first is force P, that's positive, minus the Y component or X component of our weight, W, which is going in the left direction. So this is W X component equals MA. So let us calculate the W in this side. W is mass times gravity. Mass is 100 kilograms and acceleration due to gravity is 9.8. So we have 980 newtons. For our substitution, here, P is 1,000. Wx is W, which is 980. And since this is X component, so we will be using cosine of the angle 60. Equals, mass is 100 kilograms and the unknown acceleration. So let us solve this. 1,000 minus 980 cosine of 60. This is equivalent to 510. Equals 100A. Divide both sides by A or by 100. So it's simply equivalent to 510 over 100. And this is 5.1 meters per second squared. So this is the acceleration of the box. Example number 2, find the acceleration of the box if P equals 1,000 Newton and M equals 100 kilograms. Assume the coefficient of kinetic friction equals 0.3. This is the same with the previous example, but this time, the surface has a kinetic friction or coefficient of kinetic friction which is 0.3. Okay, so let us draw again the free body diagram. This is the direction of force P. Force P is parallel with the incline. Okay, so again, don't forget that the incline is the x-axis in our free body diagram. Then the effect of the weight. This is the weight. So let us solve the value of weight. This is M times G. 100 kilograms times 9.8 meters per second squared. That's the unit of 9.8. And this is equivalent to 980 newtons. Okay. So the given angle 30 degrees. This is the 30 degrees, but again, we will be using the value here in computing the x component and the y component. The direction of motion is to the right. Therefore, the direction of acceleration is also to the right. And because of the friction, there is a frictional force opposite in direction with respect to the motion. So this is the direction of the frictional force. So we have additional parameter here compared to our previous example. Okay, so what else? There is a normal force perpendicular to the contact between the box and the incline. So here in the pre-body diagram, we can plot that normal force here. This is the normal force direction. Okay, so let's begin. First, let us calculate the value of normal force by using the summation of y component equals to 0. So let's begin with n. N is going upward, so positive. Minus the y component of the weight W equals 0. So meaning n is simply Wy. And Wy is W sine of theta. This is equivalent to 980 sine of 60 degrees. (980) times sine 60 degrees, use your calculator. This is equivalent to 848.70 Newton. Next, F is equivalent to mu times N. Mu is given, that is 0.3 multiplied by 848.70. Solve this value. This will give us 254.61 Newton. So this is the value of frictional force F. Now, we can now solve the acceleration. Again, F net equals mass times acceleration. For the F net, assuming and considering the direction of acceleration to the right, so therefore all forces to the right is positive. So let's begin with P. P is to the right, so positive P. F is to the left, so negative F. And the Wx is also to the left, so minus Wx equals ma. So substitution, P is 1000 Newton minus F 254.61 minus Wx, that is 980 cosine of 60 equals mass 100 kilograms times the acceleration. Okay, so solving for the left side value of the equal sign, solve this operation. This will give us 255.39. And divide both sides by 100. So acceleration is 255.39 over 100. And this is equivalent to 2.55 meters per second squared. So this is the acceleration for this example. Okay, for example number 3. So here in example number 3, it looks the same with the previous example. But take note, the force P is no longer in parallel with the incline. This is with an angle with respect to the incline. Okay? So if alpha is 30 degrees with the direction of P, it simply shows that P with respect to the incline is also 30 degrees. So again, P is 2 kilonewtons and M equals 100 kilograms. Assume frictionless. So let us draw the free body diagram here. considering again the incline as the x-axis. Okay. With respect to P, this is now, okay, this is now in this direction, 30 degrees with the incline or with the x-axis. While the effect of weight is here in the third quadrant. This is the weight. Again, this weight is equivalent to mg. This is 100 times 9.8, equivalent to 980 newtons. The given angle is 30 degrees, but we will be using the angle here, 60 degrees. Okay, so let me redraw the free body diagram. So this is, you can draw angle P here, and this is now the 30 degrees. Then you can draw W using now the required angle, 60 degrees. The direction of the acceleration is going here. Therefore, with respect to P, the x component of P is to the right, and the x component of W is to the left. So since this is frictionless scenario, we don't have to solve for n and small f. So let's begin calculating the acceleration using F net equals ma. Our F net is positive px minus wx equals ma. Substitution, P is 2000 cosine of 30 degrees minus W 980 cosine of 60 equals mass, this is 100 times the unknown acceleration. Solving for the left side, 2000 cosine 30 minus 980 cosine 60. So this will give us 1242.05 equals 100A. So divide both sides by 100 to solve for A. Therefore, we have 12.42 meters per second squared. Our last example for this video lecture, example number 4. Find the acceleration of the box if P equals 2 kilonewtons, M equals 100 kilogram. Assume UK of 0.3. This example is almost similar with example number 3. But this time, we have to consider the coefficient of kinetic friction. So for the free body diagram, okay, so this is P. P is 30 degrees with the incline or with the x-axis. Again, our incline is the x-axis. W is in the third quadrant. W has an angle the same with the angle of the incline in this direction. While the direction of acceleration or the direction of motion is to the right, it is parallel with the x-axis or the incline. So if the motion is to the right, the acceleration is in this direction, also to the right. Therefore, there is a frictional force in or to the left direction. Okay? But again, Let me redraw the free body diagram. So this is now our P. This is also 30 degrees. This is our W. And we need to use this angle, 60 degrees. Okay, it's simply 90 degrees minus this 30 degrees. That's why this is 60. And frictional force F, let us put here the frictional force F. Okay, so we have Px and we need to consider Py in this example. We have Wx and Wy here. So since there is a friction to consider, we will start our discussion with the summation of y component equals 0. By the way, there is a normal force in parallel or in perpendicular with the contact. So this is our N in the free body diagram. So let us put again N in this direction. Okay, so let's go back to summation of Fy equals 0. N is going up, so positive N. Py going down, minus Py. Wy is going down, so minus Wy equals 0. So N equals transpose Py and Wy to the right. So we have N equals Py plus Wy. Substitution for Py, it's 2000 sine of 30 degrees plus Wy, it's although we already have our W, so let us show again the calculation here. W is mg equals 100 times 9.8 and this is 980 newtons. Going back to Wy, this is 980 sine of 60 degrees. Solving for N, this is equivalent to, so let us calculate that, 2000 sine 30 plus 980 sine 60. So just use your calculator and check this answer, 1848.70 newtons. And solving for F, this is mu N. So this is 0.3 times 1848.70. And this will give us 554.61 newtons. So let us now solve the acceleration using F net equals ma. For F net, our solution is positive px minus f minus wx equals ma. Substitution for px, this is 2000 cosine 30 minus f 554.61. So let me put minus wx here. This is 980 cosine 60. Equivalent to mass 100 times the acceleration. Solving for the right side of the equal sign, that is equivalent to 687.44, then equals to 100a. So divide both sides by 100, this will give us 6.87 meters per second squared acceleration. So this is our answer for this example. Thank you for watching this video lecture. If you think you learned something from this lecture, please subscribe to this channel. Click the like button, share this with your friends and classmates, and if you want, you can leave a comment in the comment section. Thank you and God bless to all.